Okay, good afternoon everyone. My name's Kevin Loft. I work for GEMS Education and it's my pleasure to introduce Eddie Wu today. Eddie's a maths teacher from Australia and I'm not going to say any more because I've just talked to him. He is a talker. You will meet him and you'll know him by the time you leave here. Trust me.
Thank you so much. Okay, Kevin, appreciate the introduction. As Kevin mentioned, I'm from Australia, as you can tell from my strange accent. People from the US. On YouTube, they post, why does this Asian man have a British accent? Because they can't work out what it is. It's Australia, or I should say, Australia. But I'm really glad that you're all here. I'm here to talk to you about mathematics, which is my subject, and about the fact that around the world, which is fitting for a spot like the Global Education and Skills Forum, around the world we're in some serious trouble. Mathematics is widely viewed as the most difficult subject, inaccessible. It's just for very unusual people in society, and then normal people they don't do mathematics. Now, this is a real problem. This fact, for a variety of reasons. Firstly, let me just use this as an illustration. Wikipedia has a page, and I'll point out quite a well-stocked page on mathematical anxiety. I went and looked. There's no English anxiety page. There's no scientific anxiety page. Only mathematical anxiety. What's up with that? What is it about this subject that demands such an emotional response from people? This is an issue. More than that, mathematics is not just something which draws a response. It's also something which is woven into our lives more and more every day. I don't know how many of you are aware. If you've got Facebook or really any social media platform, you don't see everything that's posted by your friends and by the things that you're subscribed to. You don't see even a fraction of it. You see a little small section, the part that Facebook decides it thinks that you want the most. It uses a mathematical algorithm to do that. There are some serious problems with that. Did you know? Did you know that mathematics is governing your life in that way? This phone in my pocket and the phone in your pocket arguably knows exactly where you are to within about a 5 square meter area because it can hear signals from a network of satellites zooming around above our heads and mathematically can work out your position on the basis of that. And lastly, hands up anyone who's done online shopping in the last year or so. Anyone? Yeah, okay, a huge number of you. Thank you, hands down. Did you realize that your credit card number makes its way from you to Amazon.com by going through a series of, depending on where you live, 20 to 30 different internet servers every single time your credit card number gets copied? They all have a copy of your credit card number. How does it stay secure? The answer is mathematics is how it stays secure. But this entire world is invisible to us. We are building our world on this subject, and yet, by and large, we do not understand it. So therefore, I put to you 4 ideas for how we are going to remedy this enormous problem. 4 refocusings of mathematics that if we understand mathematics this way, I think this is the way we're going to ourselves understand this subject and even more importantly, help the next generation embrace it. So these are the 4 ideas, and you're going to be actively involved in this, which is why I hope you've got a piece of paper when you came in that looks like this. There should be a deck of cards on your table somewhere nearby, and if you have a writing implement, that'd be handy, though I do understand we have a box flying around, so if you don't have a pen, then wave your arms around wildly when we get there, and you'll get one. So firstly, mathematics as play. These are my 2 boys. I have an older daughter, and she was invited to a special party. And so I was trying to be a good dad. The boys were feeling sad that they didn't get to go trampolining and they didn't get party bags. So I took them to the playground. Now, you may not be able to tell from this angle for the photograph, but they're sitting on a playground's roundabout. So they're sitting on this little round thing, and unsuspecting parent comes along, spins the roundabout around, the children scream, and you can see on the outside, you have this netting here. Does anyone know what that's for? There's netting around this roundabout. It's because there's nothing to grab onto, so when you spin it, it stops children from flying off because of centrifugal motion. Now, this is Jamie, who's 4, Nathan, who's 7. I wonder if you can tell by the look on Nathan's face what he's about to say. Any parent in the room knows what he's about to say. He's about to say, again, one more time. It doesn't matter that you've just done it 15 times, and that's why I'm taking a photo, because I'm exhausted. He wants to go again. Now, this is a deep fact about human beings. You don't have to tell human beings to play. It's a natural human desire. They'll go, and they'll go again and again. This is a natural human instinct. Now, Dan Finkel, he's a mathematician and educator from the US. He wrote this quote, and it perplexed me a little bit the first time I read it. He said, well, books are to reading, play is to mathematics. Now, I said before that many people, I would argue many people in this room, are quite opposed to mathematics and scared of it. I think one of the primary reasons for this is because they do not understand what mathematics is. And sometimes our education system does not help them to see what it is. If play is at the core of what mathematics is, then we really need to change the way that we actually teach it. So I'm going to try and illustrate that for you right now with that piece of paper you have in front of you. Now, we're going to play a game. And you are going to need someone beside you to play this with. If between the two of you, you've got one of these pieces of paper, that's more than sufficient. So if you've got two of you, got two pieces of paper, just put one to one side. Okay. Now, we're going to play a game called Boxes. Now, in Australian schools, Boxes is a very well-known game. All you have to do is turn to the back of the book in which you are currently bored. That might be mathematics or history or science or whatever it is, and you draw these dots, okay? The aim of Boxes is very simple. As the name suggests, you take one turn at a time. Each person takes a turn, so it's a competitive game, and you join up a pair of dots. The goal of the game is to make boxes. So, see this over here? See this? Whoever made the last stroke and completed the box now owns that box. So for example, I might have made all of these marks over here, but if Craig made the last line up the top, that one, that's Craig's box now. Okay. Now the aim of normal boxes is just to get more boxes, and you'd probably put, the letter C there to indicate this belongs to Craig. But I've got something a little bit different. You can see the boxes you've got in front of you have numbers in them. Do you see them? I believe this one is the one on the top right-hand side. Okay? This is the board we're going to play. This game is not just boxes. I like to call it mean boxes. Not mean as in cruel, mean as in a mathematical mean. That's just another word for average. The goal here is not just to make more boxes. The goal here is to get the boxes that will give you the highest mean, the highest average. So, for instance, there are some boxes that are quite desirable. Everyone's going to want to get the 9, right? There are some boxes that are undesirable. You want to avoid the 0, you want to make your friend get the 0. If, of course, for instance, after you've played this game, you've got the 9 and the 0, what is the average of 9 and 0? Well, it's 4.5. You add them, you divide by 2. If I had another box, if I had 9, 1, and 0, I would add them all up, and I would divide by 3, because that's how many I've got. Now, you have pens. You have a board in front of you, and a person next to you who you are either going to crush or be crushed by. I'm going to give you 3 minutes. May the best players win. Off you go. Now, at this point, keep playing, don't stop. At this point, the game starts to slow down. At the beginning, you just put lines anywhere, who cares? But now suddenly something's on the line. Now suddenly, I have a chance at winning if only I can corner Eric into getting that 0, right? So I'm gonna make it sudden death, put those final lines in, and then I want you've got a phone there, use it to calculate your average. Find out who's got a higher mean. That's what you're doing. Okay, so were there any victors in the room? Who won? Who crushed the person? Mark, I knew you would. Good job, Sharon. I'm glad someone destroyed Jason. Okay, now, just freeze for a moment. Just freeze for a moment. What just happened? And the answer is, mathematics is what just happened. In chess, once upon a time, because I'm a nerd, I used to play chess. And in chess, the whole game is to read ahead, to try and predict what your opponent will do. Now, in this game, reading ahead means thinking mathematically. Play is at the heart of what this subject is. Okay, now I need to zip through because, again, I'm watching the time. Kevin's laughing at me somewhere. Mathematics is more than just play. It is also exploration. Al Gore introduced this for me. I can't believe it. I made this presentation months ago. Al Gore referred to the fact that when JFK wanted to galvanize a nation in the heart of the Cold War, he said, we choose to go to the moon. Now, here's what I want to put to you. Why? Trillions of dollars, tens of thousands of men and women who put their intellect into getting onto this lifeless, dead rock? Why? And the answer is, as human beings, we see innate value in going places we've never been before. We see innate value in exploration. And mathematics at its core is not about the exploration of a place we haven't been. It's the exploration of a place our minds haven't been. So let me show you what this looks like. I'm going to skip that for time. Have a look at this diagram with me. Now, I'm going to try and describe it as best I can. You start with a triangle. It's been divided into pieces. I apologize if you're colorblind. But then the pieces rearrange. Now, upon rearrangement, something unusual happens. Do you see it? When it ends, you get this hole. Now, I admit, it's a bit hard to see when it's all moving. What's going on? How can you take a shape, just chop it into pieces, and then rearrange it, and it ends up being different in size by the end? If you count, it's a bit hard to see on the screen, but that triangle is 13 units across, it's 5 units high. Most people will remember that the area of a triangle is half the base times the height. If I'm doing my numbers right, I think that makes that top triangle 32.5 square units. But this one is 31.5. Now, I could tell you why this is. I could show you exactly what's going on, but my point is to put you in the place where now you need to explore. Now you need to see what's going on here. Why is this happening? Let me try and show you this another way. You have that deck of cards in front of you. You're going to need to use it. Open it up if you haven't opened it already. And what we're going to do is a little card trick. So you've got them all in front of you. If you'd like, just quickly inspect it. You can see it's not like a trick deck or anything like that. It's a completely normal deck of cards, 52 playing cards. And I'm going to deal them out in front of me in a particular way. And I want you to do the same with me. I've got one more spare, if you like. Okay? So here's what I'm going to do. I hope you can follow. Okay? You've got your deck. I'm going to look at the very first card. Would you look at the very first card? My one is red. Okay? So if you have a red card like me, what I'd like you to do is place it in front of you on your left. If you have a black card, put it on your right. Is that okay? If you had a red one like me, on your left. If you had a black one, put it on the right. Now, you see a card. I want you to take another card, but don't look at it this time. Take another card and put it beside whichever card you just put down. If you had a black one right here, then you can put a face-down card beside it. Is that okay? Do you see what I've done? All right, now I'm going to keep doing this. I'm going to alternate. I look at a card. This one is black, so it goes on the right. I look at one. I don't look at one. I look at one. I don't look at one. Do you see how I'm doing this? I'm looking at the color. Red's on the left, and I'm waiting till I get a black one. Black is on the, oh gee, who shuffled this? Black is on the right. There we go. So do you see? Every time I put down a card I can see, I put one down that I can't see. Now you're going to do that with the entire deck. Now as you do this, I want you to notice what's happening. Do you see these secret cards? We don't know very much about them, do we? They're completely hidden from view. I don't know how many there are because I've been busy talking to you. I noticed that there aren't the same number of cards. I have a really big fat pile over here, and this one's quite small. It's just random. Black, another black. And I'd like you to do that until you've laid down the entire deck. If you did it right, the last card you put down is one you can't see. Okay. Now, could you raise your hand if you can see the cards in front of you and they look like this, roughly? Anyway, hands up straight. Yep. Wonderful. Outstanding. Okay. Now, I'm of the belief that mathematics is a sense. Mathematics is a sense like sight or hearing or touch. It allows you to perceive the world. And mathematically, I can sense something here. Let me square it up a little for you. I can sense something here, a pattern that you cannot see yet. I'm going to change it. Watch. You know these cards up here, the ones that you know nothing about? I'm going to make a prediction of them. I'm not just going to make a prediction of my cards, I'm going to make a prediction of yours as well. There's a red side and a black side. I predict that in this deck over here, on the red side, the number of red cards in this secret pile is the same as the number of black cards in this secret pile. I'll say that again. The number of red cards here on the left, which I can't see, I predict is the same as the number of black cards over here that I can't see. Now, I'm a mathematician, not a calculator, so I need your help to help me count these, okay? We're going to look at these, and we're only going to count them if they are red. All right, you ready? So, I need you to help me count aloud as well. So, 1, 2, yeah, okay, you're not as good at counting either. 4, 5, 6. Sorry. 10. 10. Do you remember what my prediction was? I predicted the number of red cards over here would match the number of black cards over here. So let me move these aside. Let's see if it actually works. How many red cards did you count? 10. All right, here we go. 1, 2, 3, 4, 5, 6, 7, 8. Nope, sorry. 7, 8, 9, 10. Thank you, ladies and gentlemen. Now, I did that for my cards. You have cards in front of you too, don't you? Have you counted yet? Did they match? Now, here's the interesting question. Did you also get, like I did you get 10 and 10, or did you get a different number?
A different number.
What number did you get? 12 and 12. Who got a different number, not 10 or 12? What else did we get? James? 13 and 13. Did I get any 7s? 11 and 11? 7 and 7. Now, what's going on here? Okay. Now, I will leave it as an exercise to the reader. I can explain to you afterwards at lunch if you like. But my point is, what's going on here? At this moment in time, whoa, hello. Yeah, that was totally planned. At this moment in time, you are exploring. You are a place that your brain has never been before. And if you feel perplexed, that's okay. Explorers are, by definition, lost, and they don't know where they are. That's what it means to be an explorer. I use this topic to introduce Year 7, Grade 7 algebra, because you notice that all our numbers are different. I had 10 and 10, 12 and 12, 7 and 7, because algebra is the superpower of dealing with numbers that may vary, but I can still see the same pattern in them nonetheless. Okay, let's bring this home. That was that. Let's move on. Okay. We said mathematics was play. We said mathematics was exploration. Mathematics is a story as well. I said to you, my daughter, that's Emily, she's 9 years old, and Emily and Nathan are reading a book by David Walliams. I think it's Bad Dad from memory. I don't know what that's supposed to say. Now, mathematics is a story. People do not often connect the idea of a narrative with the subject of mathematics, which is a shame, because stories are powerful. And my son, who's youngest, he has slightly different tastes in reading. He's currently reading Nobot, the robot with no bottom. Now, stories have this unique power to land us in another world. Emily and Nathan, I'm dead to them right now. I could be lit on fire, and they wouldn't care because they are in the world of this story. And Jamie, you can see it on his face, right? Stories evoke joy and surprise. And mathematics has some great stories in it. Let me tell you one of my favorites. Geometry is a subject that strikes fear into the hearts of students everywhere because it is known as a subject that's all about rules set in stone, that someone came down from a mountain once upon a time and said, "These are the laws of geometry and they shall be true forever." It's a shame that people think of geometry this way because geometry is in fact not like that at all. Geometry is not set in stone. It's actually a rolling ocean of logic that is still changing today, which is why I don't call it geometry when I introduce it to my Year 8 students. I call it the global, very fitting, geometry project. It spanned the entire world, and it's also gone ongoing like a project throughout history. We've been looking at it for centuries, and we are still looking at it today. There's an amazing story behind here. Let me introduce you to some of the characters. We have to start with this individual. Does anyone know who this is? If you squint and look at his hands. Do we have any Greek people in the room? Anyone? Anyone? Pythagoras is a very good guess, but this is one of his compatriots. This is Euclid. Now, Euclid in 300 BC was obsessed with perfect shapes because the ancient Greeks were obsessed with perfect everything. They had a god of war, they had a god of wisdom. They had perfect ideas of everything in reality, and that's why Euclid said, well, what if in geometry there was such a thing as perfection? And so he explored shapes with perfectly straight lines and circles which were perfectly round. And we are still looking at those shapes today. In fact, everything in a normal, in an average class around the world, from kindergarten to year 12 that we look at in geometry, we owe to Euclid. In fact, people might know that the subject is often called Euclidean geometry. But geometry did not stop with Euclid and his flat shapes. They moved on. This character here, be surprised if anyone knows who he is because his name is hard to pronounce. This is Nikolai Lobachevsky. And I said it was a global project, right? I wasn't lying. He said, well, this is funny. We've been looking at these flat shapes for centuries, but that's kind of unusual because we do not live on a flat shape. I know it looks flat, but that's just because we are small and it is big. In fact, we live on a curved shape. Al Gore showed it to us earlier. It's roughly a sphere. So he said, I wonder if there is some interesting mathematics there. He explored these kinds of shapes. This is called a saddle. And unwittingly, he unleashed a fast food revolution, which is still affecting us today. Now, this geometry that Lobachevsky was exploring, he wasn't trying to solve any problems. He was just trying to explore. Until this man came along, who of course needs no introduction. Now, Einstein was trying to solve an interesting problem. Einstein was trying to work out how gravity worked. Now, gravity, you might think, is a strange problem to be perplexed by because we feel gravity all the time, all around us. Every day we can't stop it. It's so normal to our experience. But actually, gravity is mysterious. I'll just give you one example. The Earth's gravity. The Earth's gravity is incredibly weak. It's incredibly weak. Me, with my pathetic muscles here, I can overcome an entire planet of gravity, and I'm just this tiny little object. Why is gravity so weak? And then he stumbled upon Lobachevsky's equations. And he said, what if space and time itself were not flat, even though the solar system looks very flat? What if it were curved? And lo and behold, he gave us the theory of relativity that helps us understand and see that space and time itself are curved the way Lobachevsky described them. That's what geometry means. You remember I told you about our phones, which know exactly where we are because they listen to these satellites up in space? GPS is amazing, except for that time when it wasn't, when it didn't work, because time here on Earth runs differently to time up on the satellites because of relativity, because of the curvature of space. That's what geometry means. And geometry didn't stop with Einstein. This is my favorite mathematician of all time, which is saying something because I know a lot of them. This is Benoit Mandelbrot, a Polish mathematician. And he was really interested in the world that he saw around him. And he looked and he said, well, there are some shapes that neither Euclid nor Lobachevsky nor Einstein can describe. That's a river delta, in case you can't quite tell, where the ocean meets land. And I defy any of you to look at this photograph and say, there's no pattern here. There's no shapes. There's no geometry. There's an amazing set of structures underneath here. They're not flat, are not round. They're broken. they're shattered into pieces. So he called these shapes fractals, like the fracture of a bone. They're broken apart. And he invented a whole new field of geometry. And this field of geometry, fractal geometry, explains everything. You know that river delta that you can see there? The veins and arteries that run through your body, that deliver blood to every cell that is you, are in exactly the same shape. You, my friends, are all made of fractals. That's what geometry means to me. And geometry is still moving today. When I was at school, I learned that atoms looked like this. And you've got the nucleus in the middle, and you have the electrons doing their wonderful, orderly things around the edges. And then I discovered, once I became a teacher and I spoke to my science colleagues, that my entire life was a lie. That's not what atoms do at all. In fact, that the electrons do not go around in nice, orderly orbits. They actually weave in and out of 11-dimensional space, appearing and then disappearing and then reappearing and then being in two places at once. That's geometry. There's an amazing story underneath here that is still going on today. That's what mathematics is to me. So lastly, mathematics is play, it's exploration, it is an amazing story, but most importantly, it is yours. Now, this might be a strange note to end on, but I said I would get it out again. 5 years ago, I started filming my lessons and putting them online for free. And I did that to help a single student who was very ill. But what I discovered is that this unlocked people around the world to be able to actually take hold of mathematics for themselves, to be in the driver's seat, to no longer be like I was when I was at school, being told, okay, this is what you're learning, this is why you're learning it, because I say so, and this is what it is right. There's only one answer. You're wrong otherwise. What I've been able to do through the power of technology is put learning in your hands, in a child's hands. Instead of watching Rihanna and Justin Bieber on their phones, they can actually learn mathematics wherever they are on the planet. And mathematics should belong to all of you, not to some keepers of knowledge. So, I can't show you, unfortunately, because the screen is not quite there. It's all wiped out. Let me see if I can do it this way. It's very bright, but if I look over this map, you can see every country on the planet. Let me go to, where are we? UAE, where are you? There it is. United Arab Emirates, 60,149 views. Now, this is astonishing to me. You can go to a place that's almost entirely ice, like Greenland, and there are people there learning mathematics because it belongs to each and every one of us. So, in conclusion, how are we going to fix this worldwide problem about people and their view of mathematics? Well, if we can see this subject as playful and inquisitive, with a narrative thread, and as belonging to us, not to someone else, special individuals out there, then this is the way that we can all embrace this subject and find joy in it. Thank you.
We're just going to do 2 or 3 questions initially in the room, and then Eddie will move over to here to take any other questions while we get our next speaker set up. Are there any questions for Eddie?
Stunned into silence.
Okay.
That's it.
Done the job.
It's fine. I'm okay with that.
Thank you. Amira, I'm from London.
Hi.
Hi. I wonder whether you provide training for other teachers and how to inspire.
I couldn't have been asked a better question. Let me go right back to the start. There we go. I skipped over this because of time, but it disappeared. You turned me off. Can we go back, please? Thank you. My substantive role is the head of mathematics at Cherrybrook Technology High School, which is a school of 2,000 students in Sydney, Australia. But over the last 2 months, and for the next 2 years, I've been seconded to a position with my state's department, which allows me to travel all around the state, and I've been doing a bit of travel around the country, actually, in order to help students and teachers embrace mathematics and become more confident and competent teachers of it. So I'm very excited about those opportunities. I spent last week, before I flew here, I spent 3 days in sort of country New South Wales, out in areas where people traveled 2-3 hours longer on a bus than I traveled on a plane to get there in order to experience this, because I think the need is desperate out there to really understand that mathematics is so much more than just numbers and calculations and formulas. So that's a long way of saying yes.
Yeah, hi. I'm a special education teacher in India, and I was wondering if you have some videos or some tutorials or articles to help teachers or help teach children with learning disabilities in mathematics.
This is the question about learning disabilities is an area I'm just starting to move out into. I don't know if you knew this, but dyslexia is commonly recognized as a disorder that obviously affects many children around the world. What less people know about is dyscalculia. Dyslexia, dyscalculia, the inability to resolve numbers and work with algebra. And it's absolutely, that's right. Now, it's a space that I'm trying to move into. This that I've been doing has just been me in my garage putting videos up. And whatever happens tonight and with the announcement, what I'm excited about is the opportunity to do more with that and to work into a space like that, because I know the need is so immense.
Hi. So, what's the difference between you and other websites like Khan Academy?
Who here has seen Khan Academy? Hands up. Okay, so if you've seen it, or I should say if you've heard it, then you know the difference, which is that Salman Khan speaks in this lovely, calming, soothing voice that makes me less stressed out after a day. Clearly, that's not me. I also do my, if I can show you, what I put online is not something done in there we go. It's not something done in a studio with a computer and a microphone. That's my classroom with a whiteboard affixed to a blackboard, because that's how we do it in public schools. It's the live experience, and in fact, the involvement and contributions of the students in the classroom are somewhat what make my videos what they are, because I can see when they have a look of confusion or perplexity or surprised joy on their faces, and that's kind of what characterizes my lessons. So Salman Khan and I are on the same team. It's great to call him a colleague. I haven't met him yet. I'm going to meet him in a couple of months.
We'll take
that's what makes it different.
One more question, and then Eddie will be over here, so you can come up and ask him when we're done.
Hi, Eddie. I'm a teacher from India. I teach math, and I spend a lot of time in my teaching career trying to deal with math anxiety a lot. Like, how much have you come across it, and what specific things have you done to counter it in, let's say, your class?
The question is about mathematical anxiety, which I did refer to. And I think the solution to mathematical anxiety is both simpler and more difficult than most people realize. When I was at school, I didn't mention this before because of time, but I struggled deeply with mathematics. It was not my favorite subject. English and history were my favorite subjects, which maybe explains part of what I just presented. Mathematics was a struggle to me, and when I was in class, often the experience was, "Sir, I don't understand." And then, actually it wouldn't be Mr. Jamison because he's a much better maths teacher than this, but Mr. Jamison might say, "Eddie, why don't you see it? It's obvious. Let me say the same thing that I just said to you 5 minutes ago, slower and louder, as if you're a foreign tourist." And I came away feeling from that, the reason I don't understand is because I'm stupid and I'm not good enough to do this. And children carry around what I call mathematical scars. They've been experiencing that for 5, 10 years. And then they come into my class, and it takes me, the most challenging student I ever had was a 15-year-old boy who was only in school because the minimum school leaving age in Australia is 17. And so he was just stuck with me for 2 years, and he was trying to get a construction building apprenticeship happening, and his paperwork was not lining up. It took me about 3 weeks of me coming in and saying, "No, Daniel, I believe you can do this. Let me help you. Let me come in beside you." It took me 3 weeks to help him understand. You know that game that you played, that Mean Boxers game? He was the best at that game. He crushed everyone else in the room. And then 3 minutes later, he'd say, "Sir, I can't do mathematics." I had to convince him and tell him, "No, you're doing mathematics now." And that's much easier than, I don't think you need a program or a big structure or even huge amounts of money to do that. But what's challenging about that is that it demands a personal approach. That demands the time for me to be able to sit next to Daniel and give him that personal view. It's very simple. but it's a time-consuming personal way to do things, and that's what makes it hard. And the fact that teachers struggle, I don't blame my teachers for doing it that way. They were just strapped for time. They didn't have the time to help me because it would have taken way too long. But that's what we need to overcome the mathematical anxiety we see rampant in countries around the world.
Okay, can we have a big round of applause for Eddie?
Thank you.
Thank you.